In this video, I'm going to go over graphing polynomials, and this will be the first of two videos. So the first thing we're going to start with is I'm going to answer these questions. These questions will help graph this function. So we have the function there, and a lot of this I'm going to go pretty quick so the video isn't too long. You may need to pause it, rewind it to get what I'm saying. So first, to start with the zeros. The zeros you get from your factors. We've done this throughout the unit. So for example, if you had x plus 2, you're going to take x plus 2, set it equal to 0. So you take your factors, set them equal to 0, and solve. So you subtract 2, you get x equals negative 2. So that's how we get our zeros. So from these factors, x plus 2, you're going to get a 0 of negative 2. X minus 1, you're going to get a 0 of positive 1 when you set that equal to 0 and solve. X minus 4, when you set that equal to 0 and solve, you're going to get positive 4. Now, the way zeros are important, zeros are also going to be our x-intercepts. So if I have a 0 of negative 2, that means this graph is going to cross the x-axis and intercept it at negative 2. So negative 2, we have that point. We can write the coordinates for this x-intercept. So by coordinates, the xy coordinates. So that is negative 2 for x. My y value is going to be 0. For 1, I can put that 0 on my graph. That is going to be the coordinate 1, 0. And 4 is all the way down here. The coordinates of that x-intercept are going to be 4, 0. So I have 3 x-intercepts there. Next, I can find the y-intercept. And the way we find y-intercepts is very similar to x-intercepts. X-intercepts, notice if you want the x-intercept, the y values are all 0. So if you want the y-intercept, your x value is 0. So what you're going to do is you're going to plug in 0 into this graph. So you'd have y equals 1/4, 0 plus 2 times 0 minus 1 times 0 minus 4. That point on, it's just an order of operations problem. I'm not going to show all the work for that. You can pause and work it out. But when you work all that out, you're going to get 2 for y. So our y-intercept is going to be at 0, 2, which is up there. All right. Next, it says, what is the general shape and end behavior? Now, how we know the general shape has a lot to do with the zeros. So we had 3 zeros. So what that tells you is the degree of this function is going to be 3, meaning the highest power of x is going to be x to the third. And what we talked about in class is when the degree, which is the highest power, when it's odd, you're going to get an S shape, something like that. If the number of zeros was even, so say if I had 4 zeros there, it would be x to the fourth, you're going to get a U shape. So right now, I know it's going to be some sort of S shape. The other thing we have to pay attention to is we have to think back to transformations. We have to think back, what is A? So thinking back to transformations, I have videos on transformations. A can also reflect this. So A is positive 1/4. So this, I know, is going to be an S curve going up. If A would have been a negative number, that would just reflect both of these basic graphs over the x-axis. So instead of an S going up, that's if it was a positive. If A was negative, this would be an S coming down. Or if it was an even function and negative, that would be a U coming down. So I know it's going to be an S going up. So what we could do next is I'm going to use the graphing calculator to help us through graphing this. So what I did is I went to my calculator and went to y equals, and I typed in my function. So I typed in 1/4, x plus 2 in parentheses, x minus 1 in parentheses, x minus 4. I have it all typed in to save us time. So what you can do is you can hit graph. Now there's a few things here that I confirm and know I'm doing this correctly. So I have this S shape up, just like I said there would be an S shape up. The other thing I noticed is, see, I had 3 zeros, 3 x-intercepts. Well, if I look at my graph, 1, 2, 3, and then I knew I would have my y-intercept a little bit above, which I have as well. The only thing left to do is we're going to calculate something called our local minimums and maximums. When you think a minimum, you think low point. When you think maximum, you think a high point. So what I'm going to do is I'm going to calculate local, which means just kind of in the area when you think local, close, minimums and maximums. So for example, when I look at my graph, I'm looking for a high point and a low point. So a local maximum would be, on this graph, where's a point where there's a little bit of a peak? If you look, it's at this area right here. What we could do is you can use your graphing calculator to calculate that for us. What you're going to do is you're going to go to second, and if you look at your options, you need to have your graph pulled up when you do this. In blue, you see calc. Now we're going to have a whole bunch of options there. I'm looking for the local maximum. Notice how minimum's there. We're going to use that in a second. So I'm going to go down to option 4. It's going to ask you 3 questions. It's going to ask for the left bound, right bound, and then a guess. What it means by left bound, so since I'm trying to find what that point is there, and more specifically, I'm trying to figure out how much does this graph dip. So, we've talked about in class how much dip there is in the graph. Well, today this is how we figure out how much dip there is. So since I'm focusing on this point here, I'm going to move the little X a little bit to the left. So it's asking you, hey, go a little bit to the left, hit enter. And now it's going to ask you, hey, go a little bit to the right. So I'm going to go a little bit to the right of that point I was talking about. We'll go about there, hit enter. And then it wants us to guess the location. So I put my little X crosshair, that's close enough, hit enter. And on the bottom, it's going to calculate that maximum point. So what I'm going to do is I'm going to write those coordinates down. So I'm going to have a negative 0.73. I like to round to 2 decimal places. And the y value is 2.59. Now we could add that to our graph. That's going to take a little bit of, estimating. So negative 7.3 is not completely 1. And then up about 2.5, which is right around there. Next thing I'm going to do is I'm going to calculate my local minimum. Exact same process as I just did. So second calc, go down to option 3, minimum. And it's going to ask you, hey, for the left side, right side, and then, guess. So a minimum, you think low point. So we have to find the low point there. Make sure you're using minimum and not maximum on this guy, otherwise it won't work. So it's asking, go a little bit left, which is right there, hit enter. Go a little bit to the right, that's what it's asking about, a right bound. And then guess where that location is. So I use my arrows right around there and enter. And it's going to tell us 2.73 and negative 2.59. So 2.73, negative 2.59. So I can transfer that to my graph. 1, 2, 7, 3, and about down 2.5, which is right around there. Only thing left to do is actually sketch the curve here. And how I do it is I move left to right. So left to right, I'm going to go up, come down, go up. So it's going to be a weird game of connect the dots. So I'm going to start bottom left. We're going to go up, connect all my dots, come down, and go back up. So that would be my graph. And notice how my graph on my paper represents the one on the calculator.